Hi, it's Coach Tony Morgan. So today's video is from our Hints and Tips series. So in these Hints and Tips videos which I'll be doing for you, we'll be focusing on specific parts which we change, and also you'll see any snags which I can point out for you so you can avoid any mistakes and makes the job more easier for you. Now before we dive in, if you haven't already subscribed to our YouTube channel, just hit the subscribe button below, and then you can be updated for any future videos. So today's video is going to be on the ideal Icos, and today's fault will be the LF code. So we're going to be looking at various faults and hints and tips how we're going to overcome the reasons why we would get the LF code, and hopefully you're going to learn a lot in today's video. So this is the LF code. This is what you would see on the front of the boiler. Now what you can do, you can press the reset button by pressing that button there, and then the boiler might attempt to restart. So what will normally happen, you'll hear the fan run, you'll go through a pre-purge sequence, and then you'll hear an ignition. You'll normally see the blue light start flashing. That's the burner light, but it's not actually gone solid. So when it's actually lit, the solid light should be solid. So this will repeat this maybe about 4 to 5 times, and then it will go back to this LF code. So what we're going to look at today is what the reasons why we would get this code occurring. So that's what we're going to dive in and find out. Okay, so what you're going to do, you're going to obviously turn the power off to the boiler, and then we're going to get inside it. So this is the front panel, what you'll see on the ideal Icos. So to remove the front panel, you'll see here you've got 2 screws which you'll remove, and then the panel is ready to lift off. Then you've got the inner combustion cover, so we can remove the 4 screws, and then we can get inside the main heat exchanger area and see everything else inside. But before that, we're going to remove the bottom panel as well. So you can see we've got 2 screws to remove. We remove them, and then we can lift that bottom panel away, and we can see inside the area we're going to be working on. We'll also remove the 2 screws from here and here, and we're going to drop down the PCB and control panel so it can give us better access into the boiler of the areas where we're going to be working on. Here you can see the PCB has now been lowered down. You can see at the back you've got like a little track. It's difficult to see, but you can see by the arrows left and right, here and here. You pull that forward, and then that'll give you more access to get into the side of the boiler. So let's look at the possible faults what we could get with the LF code. So the first one is the gas valve. Now this is probably the mostly highly unlikely problem what you're going to get with this LF code, but it's also a possibility. So the gas valve could cause this by simply not opening, failing, or you could simply have no gas on. So you check here at the inlet test nipple, check there to see if you've got any standing pressure. Obviously if you haven't, then you've got a gas issue problem, and it's probably your meter. The emergency control valve closed. If that's open, you've got standing pressure, then what the next thing you can do is run the boiler and see if that standing pressure drops. Now if it doesn't drop when it goes to ignition, then you definitely got a gas valve problem, it's not opening. So that's the area what you can look in regarding the gas valve. Now what we've got here, this is your basically burner and heat exchanger. So the burner is pointing downwards. So on the left hand side you've got your your flame detection probe, and on the right hand side you've got your spark electrode. Now these 2 components can also give this LF code. There's also another area what could be give this LF code, which is probably highly unlikely, but I'll let you know about it. Now inside the heat exchanger, just above it where the burner is, you've got insulation panels inside there. Now what can happen, the insulation panels can fall down, go over onto the flame detection probe, and so when it goes to ignite, the flame detection probe cannot see the burner, the flame, and then it will give you no detection and throw at that fault. That's very highly unlikely. But what we'll do when we go through all the checks, what we're going to go through now, and if they're all good and no problems in them areas, then that's what you'll be looking at as your last resort. So let's look at the spark electrode. So you can see here, this is how we take the spark electrode out. If you've got an Allen key like this, and then that can undo the bolts. So you undo them and then you can take the spark electrode out. So this is a spark electrode removed. Now you can see the spark gap, it's not too bad. That's what it's supposed to be. That shape is what it's supposed to be. But you can get them very misshaped and nothing like this. So if they're really misshaped, then that's going to want replacing, and that could give you that fault what we just spoke about, the LF code. So this is the type of shape what the spark electrode should always be. Now in this tip, what I'm going to show you here, this is basically to see if we've got a spark in the first place. So what we do, as I said, we've removed the spark electrode and you put it into the holder like this and put it just at the side of the burner, just like we can see in this illustration now. So what you do, you turn the boiler on and you watch for the spark. So you see if you've got a good spark coming between the spark gap. Now if you haven't got no spark coming here, appearing, then you could be looking at the spark generator. So as I said, this is your first tip. Do it like this to see if you've got a spark. What you can do as well, you can give the spark electrode a clean. So basically use your file, give that a nice clean up, and then put the electrode back. So that's something you can do on a routine service. It's also just good to do this, a good practice. So now we're looking at the flame detection electrode. So we're going to just remove that as well, just the same way, using the same Allen key, and then undo the bolts, and then you can remove it. You notice that it's got the curve on the shape of that spark electrode, flame detection electrode, so that makes sure it goes back that way once you're putting it back. Again, with this electrode you can give it a clean. I suggest you do that because this can also give that fault, because what can happen along the circumference of the flame detection electrode, you can get a lot of pitting building up, and that can cause an insulation and stop it actually sensing the flame and give the LF code. So by just merely giving it a good filing, that can give then the clean surface area, put it back, and that can also, you know, help and rectify the fault what we just said. So this is another tip what you can do to eradicate that LF code. Just showing you that it's been cleaned and that's ready to go back. So another tip regarding the LF code is the electrode lead itself. So what we got here, you could get a breakdown on the lead. So if you look carefully at the top, you can see a bit of wire. So the actual insulation of the black cable, the sheathing, is breaking down. So you need to inspect that lead, see if there's any breaking down. You can see any wire. That means that could be causing the problem as well. So inspect that cable all the way through and make sure there's no breaking down. Now what we're going to do, we're going to assume that that cable has broken down and we have to replace it. So I'm just going to go through how we would replace the detection lead. So what we've done here, we've pulled the plug off the electrode and we're going to cut the wire just like this. Now the reason why we're going to cut it like that, because it's got to go a specific way once we put the new one in, and you'll see what I mean. So once it's cut, then you're going to pull it through just like this downwards, and then you're going to remove the rest of the cable. So what you're going to do next is detach the rest of the cable from the PCB. So here you squeeze that, pull the plug out of the PCB, and then you can start removing the rest of it. Now also you've got the earth cable, which we're going to detach from the chassis of the boiler. So with a spanner you undo the securing nut which holds all the earth connections to the chassis of the boiler, and then remove the lead in question. So the lead is now being removed. So this is another great tip. What you can do, in fact I made this mistake myself, but what I did, I put the lead back, put everything into the PCB, connected the earth plug, put the lead up to the electrode, and then realised that the cable was outside the boiler. So I had to redo it all again. So this is a great tip for you. So what you do, don't do, this is the first thing what you're going to do. You're going to get the new lead and hold it just like I've got it now. And you're going to push it downwards in the position shown through the grommet and then out the other side of the boiler. So you can see it go through the grommet and downwards. And then the other side of that lead is the plug, which is going to go onto the sensing electrode. Then you feed that through the boiler over towards the PCB area. Now what you do, this is your new earth lead and the plug that's going to go into the PCB. But before that goes into the PCB, you can then connect the black lead which you just shove through the grommet, and then connect that into that top part of the plug, so that both connections are in that plug ready to go into the PCB. Then you just simply push that into the socket of the PCB and just make sure it's all home. Then reconnect the earth lead onto the chassis, and then you're ready then to tighten up the nut again. And as I said, just tighten up the nut. Then you can simply just put your lead onto your flame sensing electrode, and then that's all done, and that's what you do. Incidentally, on my Mastered Basics course, if you take that course, in the part where we talk about multimeter testing, we talk about this actual test, how you check the milliamps going from the flame sensing electrode to the PCB. So here's another tip why you will get the LF code, and that would be the condensed trap that could be blocked. So what we're going to do, we're going to look at the condensed trap of its removal and cleaning it out. So you can see you've got a connection here which undo, and also you can see a location screw, that's a securing screw. There's one on the left and one on the right. So we'll remove this one first and then we'll remove the other side. So with your screwdriver, remove both the screws. Then with some small grips, undo that white connection nut, undo that from the trap, and then it's ready to be removed from the boiler. Just pull that down and then withdraw from the boiler. Then you can check to see if it's blocked. Now in some cases when it is blocked, what you would do, you'd have to have a bowl and put underneath the boiler, because once you pull it down you could get a lot of water coming out there, so you have to be very careful. But obviously if it's like this and it's not too bad, then you can take that then to the kitchen sink and give it a good cleaning out. So with a screwdriver you just can clean it out, put it under the tap and make sure that it's running free through the trap. Then just simply pull it back, make sure you leave a bit of water in the trap as a seal, and then just do the reverse what you just seen before. So you just tighten up the screws and away you go. So then you can start putting things back now, so you can put the PCB housing back to slide it back up, and then connect the two screws which secure it at the front. So then you can turn the boiler on and then give it a test. So as I said, these are the areas what we've gone over, the spark electrode, the flame sensing electrode, the gas valve, the condensed trap. And as I said, once you've checked all of them, if they are okay, also we've done the flame sensing lead as well. Now if that was all good and you were still getting the same fault, then as I said, the last thing would be the insulation pads inside the burner area. They would have failed, and then you'd have to take the burner, the fan out, the burner cover off, get new panels and replace them, because that's what would be causing a problem. So the only thing left now is to put everything back together. So you just do everything that's reverse, put the inner combustion cover on like this, the front panel, the bottom panel, put all them back, and then hopefully you've covered the bases. One of them was the fault, and then it's Bob's your uncle and everything's all good. So that's going to be the end of this video. Hopefully you learnt something from today. So if you've got any questions, just pop the a comment below. Also, if you've not heard, I'm doing online training which it helps new and existing engineers, or even if you're doing your gas portfolio. So if you click on the link below and find out more about my online training. So that's going to be it for me, and hopefully I'll see you on the next video. Bye for now.